Hello, I'm Pranav Nair, and on behalf of my team, I'm going to be explaining how we implemented domain invariant fake news detection. There were multiple steps to this particular problem. So, the first step would be to collect fake news, and we chose to collect our fake news from a singular source called fakenews.com. This is a website on which users are allowed to sign up and upload their own fake news. So all the news over here is guaranteed to be fake, some satirical, some not. So we decided that it's a good collection of fake news to collect from. What we did is we selected 5 individual categories and we scraped articles from that. We scraped over 700 articles in total and trained our model on the same. So the first step was obviously the scraping, for which we wrote our own scraper. And as you can see, you can actually see the different genre over here of articles that were taken from. So technology is one, sports is one, society is one. Then we have social media and politics. So those are the 5 ones that we decided to use, and those are the ones that we split into train, test, as well as validation. Just to clear it up, we have not mixed up either of these. All three of these data sets have been kept separate. The second step was pre-processing. Again, we wrote our own code for that. So there was a previous assignment in which we made our own stemmer and pre-processors. And what we did is we basically took all of these, took all this data, took this news data, which in fact I will try to show you over here. These are the links of these are links of 30 news articles from technology.txt. So we would basically run our scraper scrapnew.py, and we would collect these links, and then we would run during pre-processing. We would collect the articles from these particular links and scrape and pre-process them. So during pre-processing, most of it is just cleaning the data, right? So what we would do is we would take a particular news article and we clean it down so that all the unnecessary details, such as the template of the web page or say the author's name, any feature that we thought to be not useful for detection as an attribute for detection of fake news, we removed, we cleaned, and we made multiple CSV files, as you can see over here. This is one of them, a new scrap final 3 CSV, where we'd have the news article as well as the heading, as well as whether they are real or fake. And we use obviously multiple CSV files to handle the same. So till now I've explained the scraping as well as pre-processing. Both of them are handled by us, and this is the final file where we actually did all of the fake news detection. Right off the bat, I would say that I want to mention that we got a decent accuracy of 75% on our training set and 65% on a test set, which may not be which may not be highly accurate, or rather, which may not be too high when compared to accuracies of other face news detection models. However, it must be kept in mind that this is domain invariant, which means that this model does not take domain into account and it is not trained on a single domain. So technically, you could take an article from any domain, even though we did collect articles from 5 specific domains, because that's how news is written, right? News is written under specific domains. Even though we did collect it under domains, you could uh, ideally, technically, put in any news article from any domain, and the model should take care of the rest. And that's what happens over here. So the way this model works, an overview before I get into it, is a basic LSTM. So the LSTM in specific is defined over here. We have two dense layers in LSTM. The dense layers, obviously, so the LSTM has 64 dimensions. It outputs in 64 dimensions. And what happens after that is then passed through a dense layer to reduce it to 16 dimensions. And then finally, over here, reduced to one single dimension, which will hold a value which will tell us whether it is a fake news or real news. And the way this model works is we have a basic LSTM, on which we train all the different articles, right? With the labeled, which are labeled as fake or real. Now, when this training is done, it trains specifically on features that belong to that domain. So the LSTM In fact, if I'll show you the model of a basic LSTM. An LSTM which practically looks something like this, right? Will learn features that are specific to that particular domain. Now, what we intended to do was have an ANN, right? So we added a dense layer, and we ran an LSTM, learned domain specific features, right? So we ran each articles from each specific domain individually, learned individual features that are specific to those domains, and then we trained 5 different LSTM models that way. And what we also did is we trained one ANN um, completely on articles from all 5 domains. So this ANN now has features that are domain specific as well as domain invariant. What we assume is that these 5 different LSTM models that we train have both a domain invariant as well as domain specific features. However, each model has features that are specific to one particular domain. So now if we took these 5 different models that have features specific to that particular domain, and we sort of backprop or rather subtract these individual features from the bigger ANN model, which has features through all domains. You can see that the ANN model, which before which before could recognize features from all 5 domains, now has feature specific and now has domain specific features removed, more or less, and hence the features that remain to detect fake news are more about the semantics and more about the factual, uh, you know, factual factors, uh, excuse me, and not domain specific. And that is how the domain specific model is built. Now we must remember that uh, even though we must remember that there will be propagation of error between the 2 models, right? Because there are 6 models in total being trained. That is number of domains plus 1 would be the number of models trained, and hence the error of all of them would propagate. So even if fake news detection in general, domain specific, has an above 90% accuracy, an accuracy of about 65% is pretty decent over here. So if to just take you through the code once, we have used Keras for the same. Over here we are building our helper function, which will later help us plot the accuracy and loss, as you can see over here. We define our model over here. So no, what we do over here is create our own word embedding. So we create our word embeddings. We have thousands of words in our data set. So we could use the same to create our own word embeddings, which in fact may even help situate itself for this particular purpose and give better accuracy. And over here we define a model and run and get the accuracy over here. So that is our implementation of domain specific, domain invariant. I'm sorry, this is our implementation of domain invariant fake news detection. Thank you.